A very good evening to all the panels and judges. So today I'm going to present you about one of the projects that related to the waste to hydrogen technologies named Optimizing Hydrogen Productions through Sim Gasifications of Biodiesel-Derived Waste Glycerol and a Parametric Approach. So a little bit of introduction about these titles. So first of all, we are emphasizing on the hydrogen productions, and why we choose for the hydrogen production, it's because we are currently sourcing for the clean energy source, and we believe that by using a hydrogen fuel as our fuel stock, we can achieve a zero carbon emissions during the combustion process. And this is what the trend has been done by the global market and the global scenarios, where they are seeking for a greener hydrogen productions by using various methods of hydrogen productions that including gasifications, electrolysis, and also fermentation process. And one of the main process that has been conducted is using gasification process, where it can be used by coal and biomass. And for today's in this project, we are going to emphasize on the current waste that has been largely produced from the production of the industry, which is crude glycerols. So crude glycerol is one of the waste glycerols that form from the biodiesel productions, and these waste glycerols can be treated to form another alternative useful syngas in the upcoming explanation. And just a little bit of the background studies for this project. First of all, we can observe in this diagram, the global demand of the hydrogen is increasing yearly, and we can expect that the demand of the hydrogen will be further increased in the upcoming year by using as one of the materials for the refinery industries, used for ammonia and also other stuff like using for fuels. And we can also observe in these pie charts that almost 6% of the portions from the hydrogens that stands firm for the important piece for the net zero emissions by 2050. And first of all, why are we choosing for the crude glycerols? So based on this graph, we can observe that the biodiesel productions has been increasing yearly, and it increased drastically for the biodiesel productions per billion liters. And we can also observe that when the biodiesels increase, the increase of crude glycerol trend can be also observed. However, we can also observe that when the glycerol increase, the price of the crude glycerols will be decreasing yearly, and this leads to the less market value for the crude glycerols in the upcoming futures. So we can assume that the increase of the crude glycerols will also increase the waste produced from these productions. So we need to counter these issues occurs, so that we propose the project by converting the waste glycerols into hydrogen by using a steam gasification process. So by referring to the problem statements, we have found out that the two crucial problems that occurs by following the studies of this project. First of all, it's about the overlooking of the crucial aspect of the hydrogen gas formation from the crude glycerols. So in previously, they are mainly focused on how to form the syngas and the syn fuel, including methanol and also methane from the crude glycerols, but they often less emphasize on the production of hydrogen, in which nowadays they've been using for a clean fuel alternative. And the second one is the limited attention that paid to fully optimizing the hydrogen gas yield from the crude glycerols. And we observed that previous studies, they are not optimizing the formation of hydrogen gas, but instead they are optimizing for the formation of syngas fuel, including methane gas and also other gas that can help that been used in the current fuel nowadays. So in this project, we are looking for the optimization of the hydrogen gas yield from the crude glycerols, and also to see the trend of the hydrogen gas formation from the crude glycerols. So in the objective for this project, first of all, we are going to perform a parametric studies to optimize the key parameters from the production of the hydrogen by using crude glycerols using steam gasification, and we also plan to conduct a process that can maximize the production of the hydrogen yield from the crude glycerols to aim for the highest possible yield. So just a bit explanation about the methodology on how we're going to conduct for this project. So first of all, the waste glycerols has been obtained from our previous experiment studies, and the composition was analyzed that we can observe that from the crude glycerols, the glycerol content will be around 60%, and also the 31% will be methanol. So means that they are not 100% in the pure glycerol states, and this is how the crude glycerol should behave, which should be less content of the glycerols in the crude glycerol. And the reaction route we can observe in this gasification process will be steam reforming, gas shift reactions, steam reforming of the methanol, and also steam reforming of the methane. And this is the process route that we can observe throughout the overall steam gasifications. And you can see by inserting the reactant as glycerols, water, and also methanol, it will come up with the final product, which is carbon dioxide and also hydrogen. And we also obtain the reaction coefficients and the equilibrium constants. And in this case, we are conducting a simulation studies by using Aspen HYSYS. And the fluid package here we are using for Penn-Robinson's for gases, and also Wilson package for glycerols that specifically aim to study the fluid properties for the glycerols. And we also assign a few models used in the Aspen HYSYS, and we also set some of the assumptions that can fully justify on the overall process that been used in steam gasifications. For the research parameter, we are focusing on 3 crucial parameters. The first one is the S to B ratios, following by the temperatures and also the pressures. So by observing the result for the first crucial parameter, which is the steam to glycerol ratios, we can observe that a peak of 0.57 of the hydrogen yield can be obtained when the S/G ratio is around 0.074. And we can also observe that at 0.074, we can obtain the highest production of the hydrogen gas. And this condition will be observed under the temperature of 680 degrees Celsius. Following by the temperatures, we can also observe that when the temperature is around 680, we can obtain an optimum yield for the 0.4520. And we can also observe that when the temperature is continuously increasing, the yield for the hydrogen gas will be decreasing, and the yield will be decreased up until 800 when the condition of the ratio is around 50 to 50. And the overall reactions, it's mostly favored by the lower temperature conditions, which is around the moderate exothermic behavior. So this is why we can observe that a 680% are able to produce the highest yield of 0.4520. Last but not least, about the pressures. From this diagram, we can observe that when the pressure is decreasing, we can obtain the highest possible yield. From this pressure range from 50 to 2000 kilopascal, we can observe that at 50 kilopascal, the yield is the highest. However, when we considering the cost and also the operating conditions, we can find out that the atmospheric pressures are sufficient to be taken as the best conditions to trade off between the gas yield and also the cost. This is because when we observe and compare between the pressures from atmospheric and also the 50 kilopascal, the difference are not much, and also the yield are not changing very too much. Yeah. So by optimizing the hydrogen yield, we are going to observe 2 different parameters by comparing in one parameter. So first, we can observe that when the graph trends goes up, which means that the temperature rise up, the peak of the hydrogen yield will be shift to the left. It's due by representing the decrease of the SG ratio. So means that the increase of the temperature will lead to the decrease of SG ratio to obtain the optimum hydrogen yield. So from this graph, you can observe that a height of 0.57 can be achieved precisely when the ratio is around 0.074 and the temperature is around 800, which within our parameter range. And the reduction between the ratios and the biomass can result in more higher temperature to enhance the hydrogen yield. When we refer back in the SG ratios equals to 0.074, we can clearly see that from the temperature trend, the real peak of the hydrogen yield can be obtained at around 870 degrees Celsius, and the highest possible yield can be obtained is around 0.5743. So overall conclusions for this project, we successfully obtained the highest hydrogen yield for the steam gasification using the crude waste glycerols from the biodiesel productions. And we can observe that a total of 0.074 ratios up to 800 degrees Celsius temperatures and also in atmospheric pressures can obtain the optimum hydrogen yield up to 0.57 within this project parameter range. And this value can be good and suitable to be used in the real industries to optimize the formation of hydrogen by using gasifications from the crude glycerols. And this help the productions of the hydrogen can be more efficient and also more effective to produce the largest amount of hydrogen which currently being needed for the current market studies. Yeah. So that's all for this project. Thank you.